Welcome to the Math Show Skill Drills with Mr. DeClerico. The story of factoring begins with a very important number. In ancient Southeast Asia, it was represented by this black dot, while in ancient Mesoamerica, it was represented by this shell-looking shape. But you're most familiar with the Hindu Arabic symbol 0. So why does the story of factoring start with literally nothing? Well, it's because of this property, the zero product property. It states that if A times B equals 0, then either A or B must be equal to 0. A and B, since they are multiplied, are factors. It turns out that many problems can be solved by representing them in the form A times B equals 0, which is why factoring is so important. First, we'll look at a simple type of factoring, namely factoring out a monomial, or a one-termed expression. Let's consider 4x squared minus 6x. Let's look at those coefficients 4 and 6. The GCF, or greatest common factor, of 4 and 6 is 2. And the GCF of my variables, x squared and x, would be x. Combining those GCFs with multiplication, I get 2x. So I should factor out, or undistribute, a 2x. Now, how do I know what should be left inside the parentheses? Well, consider this. I know I'm factoring out or undistributing a 2x, so I need to consider what should go here such that 2x times that would get me my original 4x squared. That, of course, is 2x, as you can see. Same goes with my second term in the parentheses. 2x times what would get me my original negative 6x? The answer, of course, is negative 3. That's how we know what should be inside our parentheses. In a sense, we can check our undistribution with a little bit of distribution. Let's look at another example. Think to yourself what the greatest common factors of our coefficients and variable expressions are, and try to factor this one on your own. Okay, I assume you've paused the video and given this one a go. Let's get to it. The GCF of 3 and 18 is 3. And the GCF of y and xy squared is y. So we would combine those and factor out a 3y. After undistributing the 3y, that's what's left in the parentheses. Feel free to check your work against mine, and then we can move on. Okay, I'll assume we're ready to go. Here is a factored trinomial. X squared plus 5x plus 6 equals x plus 2 times x plus 3. Now, why does that factorization work? Well, if I look at the x plus 2 times x plus 3, I can FOIL that, and if I do, I'll get the trinomial on the left-hand side. But that's not what we're doing in this video. We're trying to get from a trinomial on the left to a factorization on the right. How do we do that? Well, you may remember your math teacher saying something to this effect. We're looking for two numbers that add to 5, that's this 5 right here, the coefficient of x, and multiply to 6. Well, that's cool and all, and those numbers would be 2 and 3, but if you're like Mr. Penguin here, you might want to know why that's the case. That would make you a nerd, which means that I need to issue a nerd alert, because I'm going to explain why this method of factorization works rigorously. So if you're not a nerd like me, or some of you who are watching, feel free to move on to the practical applications. All right, now that I just have the nerds with me, let's get to work. We're going to consider this 2 binomial expression right here, x plus a times x plus b, where a and b are just stand-ins for constants. If I were to FOIL, I would get that. Factoring an x out of the middle 2 terms, I would get x squared plus a plus b times x plus a times b. That's why this method of factorization works, because a and b need to add to the coefficient of x, and a and b need to multiply to the constant in my original trinomial. Okay, now let's get to some practical examples. Let's look at x squared minus 9x plus 8. We're considering which two numbers add to negative 9, the coefficient of x, and multiply to 8, the constant. Well, I have a lot of numbers to consider. Let's narrow things down. Let's just look at factors of 8. Well, I have 1 times 8, negative 1 times negative 8, yes, negatives matter too, 2 times 4, and negative 2 times negative 4. Well, one of these pairings is going to work, and it's negative 1 times negative 8. So now I can factor. That trinomial factors to x minus 1, that's where the negative 1 comes into play, times x minus 8, and there's our negative 8. Cool, right? If you want to check your answer, you can FOIL x minus 1 times x minus 8, and lo and behold, you will get our original trinomial. Now here's one for you to try on your own. See if you can factor this trinomial. Pause the video and have a go. All right, I'll assume we're ready to continue. The correct answer is x minus 2 times x plus 3. If you didn't get that answer, consider this. Let's look at factors of negative 6. One of those pairings is going to work. Now here are some for you to try on your own. I'm going to mix it up a little bit. Consider each of these multi-termed expressions, one binomial and one trinomial. Use the 2 techniques that I gave you to fully factor each expression. Pause the video and give it a try. Okay, I'll assume we're ready to continue. The correct answer for number 1 is 4x times quantity 2y minus x. And the answer for the second is x minus 2 times x minus 5. If the second problem was a struggle for you, consider these factors of 10 and the fact that negative 2 and negative 5 work just fine. Hope you enjoyed this video. And if you're feeling what Mr. Penguin is feeling, check out my website in the description. And as always, be sure to click subscribe, hit the like button, and all that good stuff.